All right, let's go ahead and continue our discussion of polynomials. The next section that we're going to look at is multiplying polynomials. This comes from section 5.2 of your textbook. So there's going to be different levels of multiplying polynomials, and we're going to go through each one of them as well as talk about some special cases. So the first thing we want to talk about is multiplying monomials. Remember that monomials have only one term. So in order to do this, we're going to multiply the coefficients, and then we want to multiply each variable. Remember that when we multiply variables that have the same base, we add the exponents. So for instance, if we look at example A, we have negative 8 x to the fourth y to the 7th times 5x cubed y squared. So we start by multiplying our numbers. Negative 8 times 5 is negative 40. We combine our x's. X to the fourth times x cubed, we add the exponents, so we get x to the 7th. We combine our y's. Again, we add our exponents, and we get y to the 9th. Let's try one more. Example B, we start by multiplying our coefficients. Negative 3 times negative 4 is negative 12. We combine our a's, we add the exponents, and we get a to the 7th. Combine our b's. What is b times b to the 5th? Remember that if there is no exponent, it is implied to be a 1, so we should get b to the 6th. And if we combine our c's, we get c to the 14th. Now this is going to be fundamental when we get into our more complicated polynomials. It's basically going to be multiplying monomials, but just repeated. So let's go ahead and look at our next examples. The next thing we want to talk about is multiplying a monomial and a polynomial. And we've already really done this, except for our monomial has been just a number. In order to do this, we want to distribute, so we want to multiply each term inside the parentheses by the outside term. And from there, we want to use the procedure for multiplying monomials to simplify each term. So let's look at some examples. Now, you can do this mentally or you can do this on paper. It doesn't matter. It just depends on how comfortable you are. But what we're essentially doing is we are multiplying 2x times 3x minus 2x times 5. And so now we want to simplify each one of these little monomials. So inside each term, the first one we get 2 times 3 is 6. X times x is x squared. Minus 2 times 5 is 10. And we still have an x. All right, let's come over to example B. Same idea, we're going to distribute. And I'm just going to go ahead and do the multiplication so that this video isn't too long. So if we go ahead and multiply 3a squared b times a squared, we get 3. A squared times a squared is a to the 4th. And we still have a b. Second term, we get minus 3. We have an a squared. And b times b squared is b cubed. All right, last one. We can have not only a binomial inside the parentheses, but we can have any number of terms inside the parentheses. So let's try a trinomial. So if we look at C, we're going to do the same thing. We want to multiply everything inside by the outside term. For the first one, we get 3 times 4 is 12. X squared times x cubed is x to the 5th. Y times y squared is y cubed. And that's my first term. For my second term, I get minus 3 times 6 is 18. X squared times x squared is x to the 4th. And y times y is y squared. And for my last term, I get 3 times 2 is 6. And we still have our x squared y. Okay, so that is multiplying a monomial and a polynomial. All right, now let's go ahead and get into, this is a classic multiplication problem. We have our procedure for multiplying two binomials. And this is the one that we have the trick to remember it, which is FOIL. And all FOIL is just a memorization technique. It tells us that we want to multiply the firsts, the outsides, the insides, and the lasts. From there, we combine like terms. Now, it doesn't matter what order you multiply in. The trick is you do need to multiply everything in the first by everything in the second. So let's go ahead and look at some examples. Example A, we have x plus 7 times x plus 4. If we go ahead and multiply, again, I'm going to start by multiplying everything in the second by x, or I'm going to do my firsts. X times x is x squared. I'm going to do my outsides. X times 4 is 4x. Next, I want to multiply everything in the second by 7, or I want to do my insides. 7 times x is 7x. And my lasts, 7 times 4 is 28. From here we want to simplify, or we want to combine like terms. Remember that we're just adding or subtracting at this stage. The only thing that I can combine is my 4x and my 7x. And if we combine those, we get x squared. Remember that we're going to add our coefficients. We're going to keep the same variable. So we get 11x, and then I bring down my 28. And we're done. All right, let's try some that are a little bit more challenging. Let's come over to example B. If we go ahead and FOIL, we get 2x times x is 2x squared. Outsides, we get 2x times negative 4y is minus 8xy. Move on to our insides, we get 3y times x is, you can write this plus 3yx, but I'm going to write it as 3xy because I can, and then that way it's easier to see that we have two xy terms. And finally, our lasts, we get 3y times negative 4y is minus 12y squared. If we combine our like terms, we bring down our 2x squared. Negative 8xy and 3xy combine to give us minus 5xy. And we bring down our 12y squared, our minus 12y squared. And we're done. All right, last one. Example C. Again, if we multiply our first, we get y cubed times 2y cubed. That's going to be 2y. We add our exponents, we get 2y to the 6th. Outsides, we get minus 4y cubed. Insides, negative 5 times 2 is negative 10. We still have a y cubed. And lasts, we get negative 5 times negative 4 is positive 20. All right, combine our like terms. We bring down our 2y to the 6th. We can combine our y cubed terms, and we get negative 4 and negative 10 combined to negative 14 y cubed. And we bring down our plus 20. All right, that is our multiplying two binomials. All right, so now let's extend it even further. Let's just talk about multiplying polynomials in general. To multiply two polynomials, we want to multiply each term in the first set by each term in the second set. From there, we combine like terms. I'm going to show you two ways to do this. So the first one is going to be using a horizontal technique, just like what we did when we were working with the binomials. So the trick here is I want to start by multiplying everything in the second set by p, by my first term. So we get p times p to the 4th gives me p to the 5th. P times negative 2p cubed is minus 2p to the 4th. And p times 3 is 3p. All right, now I want to multiply everything in the second thing by the 2. So if we do this, we get 2p to the 4th. Two times negative 2p cubed is minus 4p cubed. And 2 times 3 is 6. All right, let's go ahead and simplify. Let's see here, I have p to the 5th. It doesn't have anything to combine with, so I'm going to bring it down. I can combine negative 2p to the 4th and positive 2p to the 4th. They cancel. The next one that I have is minus 4p cubed. Again, if you want to write this in descending order. We have plus 3p. And we have plus 6. Now, multiplying horizontally like this can get a little tricky, especially depending on how many terms are in each of your polynomials. So there is another method that we can use to do this, and I'm going to use it on examples B and C. Another thing that we can do is we can multiply vertically. This is going to be similar to multiplying 2 and 3 digit numbers. So for example B, one of the problems is if you're using arrows, you got your top, you got your bottom, but you do have a third one that you have to do, and so it can get a little messy. So what I'm going to do is I'm going to line these up vertically. And it doesn't matter which one you put on top and which one you put on bottom. I'm going to put my a squared plus a minus 1 on bottom. What we're going to do is something like what we do when we multiply 2 and 3 digit numbers. So starting on the right, I want to multiply everything on top by -1. So we get -1 times -5 is +5. We get -1 times 4a is -4a. And we get -1 times a squared is -a squared. Okay, next thing I want to do is I want to multiply everything on top by a. And when you do your multiplications, make sure that your like terms are lined up vertically as well. So for instance, if I multiply a times -5, I get -5a. And I want to line it up under my -4a. Just like when we multiplied 2 and 3 digit numbers, remember that you kind of slide things in. If we multiply a times 4a, I get plus 4a squared. And a times a squared is a cubed. All right, last step. We want to multiply everything on top by a squared. So a squared times -5 is -5a squared. Again, I want to put it underneath all my other a squareds. So I'm going to slide it over a little bit more. A squared times 4a is 4a cubed. And that's positive. And a squared times a squared is a to the 4th. And then now, just like when we multiply 2 and 3 digit numbers, we want to add all of these together. Now, as we are not going to have to do any carrying because we're combining variables, it doesn't matter whether you start on the left or the right. So for instance, here we have a to the 4th. We have 1 plus 4 is 5, a cubed. We have -1 plus 4 minus 5 is -2, a squared. -4 and -5 is -9, a. And then we have our constant term 5. And we're done. Now, if you want, you can kind of do a hodgepodge of these. You know, the main thing is that you multiply and you combine like terms. And so whatever organizational scheme works for you is the one that you should use. All right, let's come to example C. As I said, for me, I always like the vertical method because it just gets all my terms together. And so I'm going to go ahead and use that here. Now, one of the things that we're going to note is that we want to be careful when we do this, is make sure that we have our constant term, our x term, our x squared term, and keep going. If we skip any of these, we want to kind of leave a space just so that we have our like terms above each other, lined up vertically, so that when we get to our combining step, we aren't trying to combine like an x cubed and an x squared. So for instance here, if we go ahead and multiply, starting on the right, we get 6 times -4 is -24. It's my constant term. We get 6 times x is 6x. That's my x term. The next one, notice that there's no x squared, so I want to leave a space here. just so that we know that there's nothing there. My next one is my x cubed term. If we go ahead and multiply, we get 6 times 5x cubed is 30x cubed. All right, let's move on to our 3x. We get 3x times negative 4 is negative 12x. We get 3x times x is 3x squared. I'm going to put it here. We get 3x times 5x cubed is 15x to the fourth. I don't want to put it underneath my x cubed terms because they're not like terms, so I'm going to slide over again. I'm going to leave a space right here. And I'm going to slide over one and put my 15x to the fourth in a new column. All right, last one. We have negative 2x squared times negative 4 is 8x squared. Negative 2x squared times x is negative 2x cubed. And negative 2x squared times 5x cubed is negative 10x to the fifth. Again, I don't want to put it under my x to the fourth, so I'm going to leave a space there. And I'm going to come over to the side and make a new column. We get negative 10x to the fifth. Okay, so now when we look at this, we want to make sure that our like terms are lined up vertically. So we have our x to the fifth, our x to the fourth, our x cubes, our x squareds, our x's, and then our constant. So just make sure that everything is lined up vertically and that you're not trying to combine things that cannot be combined. So now if we go ahead and combine, we get negative 10x to the fifth plus 15x to the fourth. We get 30 minus 2 is 28 x cubed. 3 plus 8 is 11 x squared. 6 and negative 12 is negative 6x. And then we have our constant term, minus 24. Okay, so that takes care of multiplying polynomials. Last thing that we're going to look at is some special cases. These are special forms. We have two that we're going to look at. The first one is squaring a binomial. And so one thing to be careful on these ones is that the square does not distribute across addition. A plus b squared is not the same thing as a squared plus b squared. It's actually equal to a squared plus 2ab plus b squared. And similarly, for a minus b squared, we get a squared minus 2ab plus b squared. So these are some formulas that you can use. Now, me personally, I don't like memorizing formulas unless I absolutely have to. These are two formulas that you do not have to memorize. When multiplying, when squaring a binomial, the easiest thing to do is still use FOIL. So let's go ahead and see how that works. The first thing I want to do when I have y minus 5 squared is I'm going to write this as y minus 5 times y minus 5. If you write it in this notation, it's easy to see that we need to FOIL it, and that's what we should be doing. So if we go ahead and multiply this out, we get y times y is y squared. Outsides, we get minus 5y. Insides, we get minus 5y. And lasts, we get plus 25. If we combine our like terms, we get y squared. Negative 5y and negative 5y combine. They have same sign, so we're going to add and keep the sign. So we get negative 10y plus 25. Now, if you want to use the formula, because you can, what we're going to do is we're going to let A be y, we're going to let B be 5, and we want to use our second formula, the A minus B. So if we plug this in, we get, remember this is going to be A squared minus 2AB plus B squared. If we plug in, we get y squared minus 2 times y times 5 plus 5 squared. And if you simplify this, this is y squared. We can multiply our numbers. 2 times 5 is 10. Keep our y. And 5 squared is 25. So if you want to use the formula, that's fine. Okay. As I said, I don't like using the formula because it's not necessary. So let's go and look at another example. Let's look at example B. First thing I'm going to do is write it in expanded form. This is 2x plus 3y times 2x plus 3y. If we FOIL, we get 2x times 2x is 4x squared. 2x times 3y is 6xy. 3y times 2x is 6, and again I'm going to put my variables in the same order, so I want to do xy. Then 3y times 3y is 9y squared. We can combine our like terms, so we get 4x squared. We're going to bring that down. We add 6xy and 6xy, we get 12xy. And we bring down our 9y squared. All right, so that takes care of our square binomial. The other one that we have is the product of a sum and difference of two terms. This is a horrible name. Most of us know it by what it's equal to, which is known as difference of squares. We'll see this again when we get into factoring. But the thing that happens is if your binomials are exactly the same except for the signs, then it's just going to equal the firsts minus the first squareds minus the last. And so we have no middle term on this. Again, this is a formula you can use, but you don't need to. You can go ahead and just FOIL like we do with any two binomials. So for example A, let's see what happens. I'm just going to go ahead and FOIL, so we get p times p is p squared. Outsides, we get minus 5p. Insides, we get plus 5p. And lasts, we get minus 25. My 5p's, they cancel, and I am left with p squared minus 25. All right, let's try another one. Let's try 3x minus 4y times 3x plus 4y. This is difference of squares still. So if we FOIL, we get 3x times 3x is 9x squared. Our outsides, we get plus 12xy. My insides, I get minus 12, and I want to write in alphabetical order, so I'm going to do xy. And my lasts is minus 16y squared. Again, my middle terms cancel, leaving me with 9x squared minus 16y squared. All right, so those are some basic examples. Let's go ahead and look at something a little bit more complex. And the main thing we want to note is that this is still difference of squares. So if we go ahead and FOIL this, what do we get? 2xy squared times 2xy squared, we get 4. X times x is x squared. Y squared times y squared is y to the 4th. Our outsides, we get minus 2 times 3 is 6. X times x is x squared, and we still have y squared. Insides, we get 3 times 2 is 6. X times x is x squared, and we have a y squared. And finally, our lasts, we get minus 3 times 3 is 9. X times x is x squared. Now, if you multiplied correctly, you should get that the middle terms cancel out. And so we have our firsts, 4x squared y to the 4th, minus our lasts, minus 9x squared. All right, that takes care of multiplying polynomials. This should all be a review, so hopefully you're good on it. If you have any questions, please contact me. Other than that, note that the next thing that we're going to be moving on into is factoring polynomials. And so we'll be spending quite a bit of time on that because that is one of the things that most students do struggle with. All right, so go ahead, work on your homework. If you have any questions, please feel free to contact me.